Hello everyone. Today we are going to solve ATP paper that is of 2025 QP code 62. So let's start. In the first question they have given inks contain different colored substances called dyes. A student used chromatography to investigate the colored dyes contained in 6 different inks. The student drew a baseline on a sheet of chromatography paper. The student then placed a spot of each ink on the chromatography paper and set up the apparatus as shown in figure 1.1. The student made 2 errors. So chromatography experiment is given to us and we have to see the diagram that what errors are being made, and we have to note down the errors which are made by the student. So we know that the spots, the sample spots are always placed on the baseline. You can see in the diagram it is below the baseline. Okay, and second thing, the solvent or the water, the paper should always dip in the water. Okay, the solvent should be below the solvent should be between the baseline and the bottom of the paper, so the paper is also not touching the solvent. So these are the 2 errors which can be seen in the chromatography experiment done by the student. Next, state the name of equipment used to draw baseline on chromatography paper. So we always make use of a pencil, okay, because pencil is insoluble in the solvent. It is not going to dissolve in the solvent, and even after performing the chromatography we can still see the baseline. So pencil is being used here. The student corrects the errors and then carries out the chromatography. The chromatography in figure 1.2 shows the student's results. Identify an ink which could contain only one colored dye. So you have to use the figure 1.2 to answer the following questions, and they have asked us about the dye which contains only one color. Okay, so out of all of this we can see the blue one which is having only one spot. Next, deduce which ink could be mixed with the blue ink to make the black ink. You can see that this is my black ink and it is having the blue spot also. Okay, and what it would be mixed with to make black. Okay, so we have this orange ink. Okay, you can see the same spots in black also. So orange ink is used mixed with blue to make black ink. Next, deduce the color of one dye that is contained in all three of orange, green and black inks. So if you observe properly, okay, you will see that there is one dye which is present in all. They have asked us for orange, green and black. So common in all three of them you can see is your yellow dye. Okay, the top one. Second question. A student investigates the temperature change when aqueous copper 2 sulfate reacts separately with 2 different metals, zinc and iron. So we are going to do here an experiment which is based on temperature change, okay, and it is done with 2 different metals, zinc and iron. So there are 2 experiments performed here. In experiment 1, use 50 cm cube of measuring cylinder to pour 30 cm cube of aqueous copper 2 sulfate into 100 cm cube beaker. Use a thermometer to measure the temperature of the contents of the beaker. This is the temperature at time is equal to 0 seconds. Add 3 grams of zinc powder to the beaker. At the same time, start a stopwatch. Using the thermometer, continually stir the mixture in a beaker. Measure the temperature of mixture every 30 seconds for 210 seconds. Empty and rinse beaker with distilled water. You have to repeat the same experiment, but instead of zinc, next time you are going to take iron. Okay, we have to understand that they have used measuring cylinder. Okay, so once we have to read the experiment properly, underline in if there are any values given, if we have to put the values in the table. So here already the diagram of the thermometer is given from which we have to write the values. So as experiments were performed, you can see that they have given two values from the thermometer. I have noted them down. Okay, you have to write the values in one decimal place. The ones which are in decimal, that is okay. For example, 33.5, 41.5. The ones who are whole numbers, you have to write it in a one decimal place. So it's 38.0. You're supposed to write 0. Now, in the second column, we have temperature change. So how we are supposed to find temperature change? So the initial temperature that we had is 24.0 degrees Celsius. So after that, all the temperatures we get, we are going to subtract the temperatures from the final initial temperature. So 33.5 minus 24.0. Similarly, 38 minus 24.0, 41.5 minus 24.0. So that is how I'm going to find all the temperature change values for both the experiments. For experiment 2 also, it's the same way. Now, complete a suitable scale on the y-axis and plot your results for experiment 1 and experiment 2 on figure 2.1. The point at 0, 0 has been plotted for you. Draw two curves of best fit. Both the curves should start from 0, 0. Now, always, whenever we are drawing a graph, we always have to read what instructions are being given. If they have already mentioned that you have to draw a curve or a best fit line or a straight line, you have to go accordingly. Okay, so don't randomly draw any graph. Read the question whether they have mentioned it or not. Now, we have two experiments. They have not given us the y scale, okay, but they have given us what is plotted on y scale, which is temperature change. Okay, so I have already calculated the temperature change here in the table. We have to see the range first, that what is the smallest number and the highest number. So the smallest is starting from 2.0, okay, and the highest one is till 20. So I will have to take the y scale according to this range, and according to that I have plotted both the curves. Okay, I have also labeled them. Whenever you have more than one experiment, you should always label the curve, whatever name is given to the experiment. Is it experiment 1 and 2, or experiment A or B or C, like that. After plotting the curves, we have questions based on the graph. So extrapolate the curve for experiment 1 on your graph in figure 2.1 to deduce the temperature change, since time is equal to 0 seconds in experiment 1 after 240 seconds. Now, if you see that in the table we have the value till 210 seconds. Okay, but in the question they have asked us to find the value for 240 seconds. So how are we supposed to do? They have already given us a hint that we have to extrapolate the curve. So the curve ends at 210 seconds. Okay, that was my last value. I have to continue the curve. I have to extrapolate the curve. Okay, continue the curve. Now I have to find it at 240. So at x-axis I will find where is my 240. Draw a straight line towards the curve. Okay, and then wherever it meets the curve, I will again draw a line towards the y-axis. Any value which I'm getting here, I'm going to write it here. That is my answer, which is 16 degrees Celsius. You can read that here. Next, state which experiment, experiment 1 or experiment 2, is more exothermic. Explain your answer. So for that we will have to again go for the values. Now here if you see for experiment 1, the values that we get are 9.5, 14.0, 17.5, 19, 20, like that. For experiment 2, the temperature change we get is 2, 3.5, 5.0, 6.0. So we can understand that in experiment 2 we have a very less change in temperature, whereas in experiment 1 we have a greater temperature change. Okay, and that is why experiment 1 is more exothermic experiment, and the explanation will be same, that we have a greater temperature change, hence it is more exothermic. Predict the temperature of solution in experiment 1 after 3 hours. So if you see the reaction, the experiment gets completed at around 210 seconds. Okay, now once it is completed, after some time it is going to come back to its room temperature. So now they are asking us that what will be the temperature of the solution after 3 hours. So it will be back to normal temperature, which is 24 or 25 degrees Celsius. Explain why using a copper container instead of beaker would not be an improvement in this investigation. So we are performing an experiment which is based on temperature change. For an accurate temperature change, we should know that how much heat is being lost. Okay, now if we have any good conductor which is conducting the heat, we will not get accurate results. So instead of a beaker, if we are using copper is a metal, and metals are good conductor of heat, so we will not get accurate results. Describe 2 changes to the apparatus that will improve the results of this investigation. So one thing we have to always remember, that whenever we are performing any temperature change type of experiments, we have to use an insulator, or it can be polystyrene cup. Okay, insulate, or you can use a polystyrene cup. Okay, that is gonna reduce the heat loss to the surroundings, and hence we are going to get the accurate temperature change. And second, as I read the experiment, I have underlined that they have used measuring cylinder. Okay, so whenever they are using measuring cylinder, we are supposed to improvise it by using burette, because burette is more accurate than measuring cylinder. So these are some changes which you have to remember whenever it is especially based on temperature change. So you have to always use insulator to help reduce the heat loss. Okay, next we have is question 3, which is your qualitative analysis. Here you have 2 type of questions. One is where you already know the solid, and the second one where the solid is unknown, which you have to identify. So in the first question, solution A is aqueous chromium 3 chloride. It is already been known that we have chromium 3 chloride. The student divides the solution into 3 approximately equal portions and performs different tests. We are supposed to write the observations. To first portion of solution A, the student adds aqueous sodium hydroxide dropwise until it is in excess. So basically we have to write 2 observations, one which is observed when we add it in dropwise, and the second when we add it in excess. So we are supposed to find the chart. Okay, you can see here that we are having chromium, and when sodium hydroxide is being added into it, so we get green ppt, which is soluble in excess. Okay, so that is what we are gonna write it as it is. Next, to the second portion, the student adds 1 centimeter cube dilute nitric acid followed by few drops of aqueous barium nitrate. So in A, the above question, we have done test for cation. Now we are supposed to do the test for anion. So here they are doing dilute nitric acid test with barium nitrate. This test is for sulfate ions. it is for sulfate ions. But if you see our compound, we do not contain sulfate ions, we have chloride ions. So even if we perform a test for sulfate ions, there will be no change or no reaction in the solution. So hence we are going to write no change. For the next question, the student is adding dilute nitric acid followed by a few drops of aqueous silver nitrate. Okay, now nitric acid and silver nitrate is a test for halogens. So in the chart, you will see test for anions. Okay, and you will see that we have chloride, bromide and iodide. We already know that our compound is chromium chloride. Okay, so when we add silver nitrate and nitric acid, the observation we get is white precipitate. So in the observation we are going to write the same thing, that is white precipitate. Next, now here we are actually supposed to identify the unknown solution. So they have already performed the tests and observations are also written. We have to find out or identify on based on the observations that what the solid or the solution could be, or the cations and anions could be. So first of all, flame test is being carried out and we are getting red colored flame. You have to again refer to the chart where they have given you flame tests and flame colors for some metals. So red color is for lithium, so hence we have identified it as lithium. For the next test, the student adds a few drops of acidified aqueous potassium manganate, pale purple solution. Now acidified potassium manganate is test for sulfide ions. Here if you see, we have this test, acidified aqueous potassium manganate. Okay, and it changes color from purple to colorless. But if you see the question, the color remains same, purple only. Okay, so there is no change in the solution. Next, to the third, in the third test, the student adds aqueous sodium hydroxide. The solution remains colorless. So again, if we refer to the chart, after adding sodium hydroxide, there is no change. If you see in all the cations, when we are adding sodium hydroxide, we are getting precipitate, and if we add extra, either the precipitate dissolves or it does not dissolve. But in case of ammonium ions, if you see, once we add sodium hydroxide, we have to warm that and it is going to produce ammonia. Okay, so directly there is no precipitate or no observation that we can see. Okay, so when sodium hydroxide is added, solution remains colorless. So here ammonium ions are being tested. In the next test, they have given that warm the product of test 3 and the test any gas given off with damp red litmus paper. The damp red litmus paper turns red. Okay, so as we have seen that when sodium hydroxide is added and if ammonium ions are present, it is going to produce ammonia, and ammonia is being tested, which is going to turn damp red litmus paper to blue. But here there is no change in the damp red litmus paper, it remains red only, meaning ammonium ions are absent here. Now in the last test, again the student has added nitric acid and few drops of aqueous barium nitrate. In the above question, we have seen that nitric acid and barium nitrate is the test for sulfate ions, that is SO4 2 minus ions. Okay, and it is giving a white precipitate, meaning SO4 2 minus ions are present. So this is how we have identified the cations and anions which are present and absent. Now the first question, describe how to carry out flame test used in test 1. So it is for 2 marks. So how we can perform flame test is, we can dip wire into sample and place that into roaring blue flame of Bunsen burner and observe the color of the flame. Okay, you can either use a spray solution also, spray the solution in the blue flame of Bunsen burner and observe the color. That is also what you can write, which is correct. You can either use a wooden splint, okay, for testing the sample or performing the flame test. Any of these is correct. Next, identify the ion that is tested for in test 4. So, we have already written that in test 4 we have actually tried to identify ammonium ions. Okay, we have tested for ammonium ions. So, we will write NH4 plus. Identify the two ions which are in solid B. So with the help of flame test, we have found out the cation, and in test 5 we have found out our anion, which is sulfate ions. So we are gonna write both of them, the two ions, that is Li plus and SO4 2 minus. Okay, you can write the name of this cation and anion or the formula for using the chart, or if you are not able to do that, please write the name lithium and sulfate. Last question, that is plan an investigation, which is a 6 marks question. Metal spoons can be electroplated with silver. So they have clearly mentioned that it is being electroplated, meaning we have to perform electrolysis here. Okay. Describe how a metal spoon can be electroplated with silver. Include in your answer how could you determine the mass of silver electroplated onto the spoon. So by performing simple electrolysis, we also have to find out that how much amount of silver is being deposited, what is the mass of silver that is being deposited on the spoon. You are provided with solid silver nitrate, metal spoon, piece of solid silver, distilled water, and common laboratory apparatus. You must include a diagram in your answer. So they have also provided us with the space, and hence we have to draw the diagram of electrolysis. Okay, that is electroplating. So electroplating is on cathode we have the object, and the object here is clearly mentioned, that is metal spoon. So we have to draw a spoon, okay, and label it as cathode. The anode will be the metal which we have to use for electroplating. So they have also mentioned that what we are supposed to use for electroplating, that is silver. So it will be silver anode. We have to connect it with a battery. Okay, we have to also show that they are dipped in electrolyte solution. They have also given us the electrolyte which we have to use, which is solid silver nitrate. So you are supposed to write that how you have converted solid silver nitrate into an aqueous solution. Okay, so because we have to also find out the mass of silver which is electroplated on spoon, so first of all, before we start our experiment, we have to take initial mass of the spoon. So first of all, we are going to record the initial mass of spoon. Then we will make the electrolyte solution by dissolving solid silver nitrate into distilled water. Okay, that is going to make our electrolyte solution. After that, we are going to set up the whole apparatus. Okay, and dip the spoon and silver anode in the electrolyte and start performing electroplating. Now, after the electroplating is done, we have to remove the spoon dry and weigh it again, which is gonna give me my final mass. Okay, so how are you supposed to find the amount of silver which is deposited on the spoon? So mass of silver that is deposited on spoon is final mass minus initial mass. So you are supposed to write only this much points. You need not write any values for initial mass or final mass. You just have to write the formula or the method how you have performed the method. Okay, no need to involve any values for final mass or initial mass of the spoon. You just have to write the formula. So this is how you are supposed to write the plan and investigation, very short and sweet and required points only. Please don't write all the apparatus which is required, small apparatus, because that is not gonna score you any marks. You have to write specific apparatus which is having a specific use. Okay, so for example, if I have any question where it is for rate of reaction, so I am not gonna write everything, pipette, burette or beaker and everything. I will mention gas syringe because gas syringe is the apparatus where I'm going to collect the gas. So it is having a specific usage. So I will mention only that much. Hope you have understood whatever we have solved till now.